In section 5, we're going to talk about hyperbolas, which have a very similar definition to an ellipse, but look very different from an ellipse. So a hyperbola is the set of points whose difference of distance from 2 points, still called the foci, is constant. So where an ellipse was the set of points whose sum distance was the same, a hyperbola's difference of distance. And weirdly enough, it doesn't look really anything like an ellipse. What it looks like is two parabolas going in opposite directions. So there's a couple things for an ellipse. You have your center, and you have your vertices, you have your two foci, but instead of having like a co-vertice or even a directrix, kind of like an ellipse or parabola, you now have asymptotes. And instead of a major axis and a minor axis, we call them the transverse and the conjugate axis. So transverse axis is your major axis, and conjugate axis is your minor axis. So the equation of a hyperbola centered at the origin, whose transverse or major axis is along the x-axis, is a hyperbola who has two kind of parabolas that open left and right. So the difference between an ellipse and a hyperbola formula is that it is, instead of being added, it's subtracted. So you have x squared over a squared minus y squared over b squared equals 1. A is the distance from your center to your vertex. C is the distance from our center to our foci. B squared is now c squared minus a squared, and you have oblique or slant asymptotes with the equation y equals plus or minus b over ax. So the equation b isn't actually graphed like it is an ellipse. Like for the ellipse, whatever your b value was, that was your covertices, so you found b so you could actually graph it. Here, we really only find b, so we know the equation of our asymptotes. C is actually more important because that's an actual point that is graphed for our foci. And then a hyperbola centered at the origin whose transverse axis is the y-axis. So that's a hyperbola that has, your up and your down. It is y squared over a squared minus x squared over b squared equals 1. And the rest of the definition is the same, but the asymptotes are now y equals plus or minus a over bx. Because if you remember how you write the equation of a line, it's your change in y over your change in x. So the numerator always has to be the letter that goes with your y value when you're doing the equations of your asymptotes. Another difference here is with an ellipse, A was always the one that moved, and A was always bigger than B. But in this case, A squared and B squared never move. They're in the same place for the equation. X squared and y squared now move, and that's how you determine which direction your hyperbola is going. It's based on which variable is first, not which denominator is bigger. So for our first example, we want to write the equation of a hyperbola that has a center at the origin, a foci at 8, 0, a vertex at 4, 0, and we want to write the equations of our asymptotes. So I'm going to use kind of like the equation how I did with parabolas to figure out which way my hyperbola is going. So you have your center at 0, 0, and you have a vertex at 4, 0, and your foci at 8, 0. So just like with a parabola, one side of your hyperbola opens in the direction of your focus. So it goes through your vertex and opens towards your focus. So that tells me this hyperbola is opening along the x-axis. So I'm going to be using the equation x squared over a squared minus y squared over b squared equals 1. So I already know A, and I already know C, so now I just need to figure out B. So we're going to use our equation b squared equals a squared, so the distance from our center to our, c squared, the distance from our center to our focus, which is 8, so 8 squared, minus the distance from our center to our vertex, 4 squared. So we're going to have 64 minus 16, which is 48. So that tells us b squared is 48. So when we write our equation, we'll have x squared over 16 minus y squared over 48 equals 1. And that's the equation of our hyperbola. The last thing it wants us to find is the equation of our asymptotes. So we're going to do y equals plus or minus, and then it's going to be b over a. And I'm not going to write the decimal here. I do want to leave it as in its exact form. So it's going to be the square root of 48 over 4x. You don't have to write it as two separate equations. You can leave it in that form. So for our second example, we have 4y squared minus x squared equals 16. So just like an ellipse, a hyperbola has to be equal to 1. So my first step here is going to be to divide everything by 16. So 4y squared over 16 becomes y squared over 4 minus, and then x squared over 16 is still x squared over 16 equals 1. A is going to be 2, B is going to be 4, because a squared is always with first and b squared is always second. For C, we're going to use the fact that b squared, 16, equals c squared minus a squared, so minus 4. Add 4 to both sides, we get c squared is 20. We then take the square root, and C is 4.47. So when the only other thing I need in order to graph my hyperbola is my asymptotes, which is going to be y equals plus or minus. In this case, because y squared is first, it's going to be a over bx. So I'm going to have 2 over 4x, which I can simplify 2 over 4. So it becomes y equals plus or minus 1/2 x. So when I go to graph, my center is at 0, 0. My vertices, because y comes first, my vertices are along the y-axis. So I'm going to go up 2 and down 2. And I don't really need to plot my foci, so I'm not going to. So finding C, not really necessary to graph it because the foci are going to keep going up. So before I can draw the shape of my hyperbolas, I need to plot my asymptotes. So the asymptotes always go from the center. So one of my asymptotes is the equation 1/2 x. So from my center, I go up 1 over 2, and I keep doing that to get that asymptote, and I go down 1, left 2. And then I connect it using a dashed line. So that's one of my asymptotes. Now my second one is the equation y equals negative 1/2 x. So from my center, I go down 1, right 2. And then up 1, left 2. connect those with a dashed line. And we have our asymptotes. So the way our hyperbola is graphed is it goes through our vertex, but it follows kind of the slope of our asymptotes. And that's how we get the shape of our hyperbolas. For our next example, we have x squared over 2 minus y squared over 4 equals 1. So a is going to be the square root of 2, which is about 1.4. B is going to be 2. And I'm not going to go ahead and find c, because I don't really need it to graph my hyperbola. Now I need to do my equation of my asymptotes, which is going to be y equals plus or minus. And because y comes second, it's going to be b over a, which is 2 over 1.4x. And because I'm actually graphing it here, 2 over 1.4, not a nice number. It's plus or minus 1.43x. So this is not going to be a very nice equation for my asymptotes, which means it's not a very nice overlooking hyperbola. So I start with my center at 0, 0. This time, because x is first, my vertices are on my x-axis. So I actually need to go right about 1.4 and left 1.4. That gives me my vertices. And then I'm going to do a very, very rough sketch of 1.43x. It's not going to be 100% accurate. Slightly more than a slope of 1. So that's roughly what our asymptotes are going to look like. So then when I draw my hyperbolas, that's what you end up with. Okay. So similar to ellipses, you can shift hyperbolas to a new center, HK, again, where that becomes our center. And the difference here is that the asymptotes have to shift as well, because the asymptotes always start at wherever your center is. So in our example, we have find the equation of a hyperbola with a center at 4, 8, a foci at 4, negative 2, and that should say a vertex at 4, 10. And then we'll also state the equations of the asymptotes. So when I'm trying to find my equation, I'm going to use these points to help me figure out which is my major axis. So my center is at 4, 8. I have a foci at 4, negative 2. And I have a vertex at 4, 10. So wherever the focus and the vertex are in relation to your center tells you what your major axis is. So the vertex is above, the focus is below, but that tells me that my hyperbola's major axis is the y-axis, because my hyperbola is going to open up and down. So that tells me I'm going to be using the equation y minus k squared over a squared minus x minus h squared over b squared equals 1. So if you have a hyperbola whose major axis is the y-axis, not at the centered at the origin, this is the equation you would use. And we know A is our distance from our center to our vertex. So to go from 4, 8 to 4, 10 is a distance of 2. C is our distance from our center to our foci. To go from 4, 8 to 4, negative 2 is a distance of 10. Now I need to figure out B. So we know B squared equals C squared, so 10 squared, minus A squared, 2 squared. So we do 100 minus 4, which means B squared is going to be 96. So to write my equation, I don't need more than that. So we'll have y, and then the opposite of the y value from our vertex. So minus 8 squared over 4 minus x minus 4 squared over 96 equals 1. When it comes to the equation for my asymptotes, instead of being y equals, I'm going to use whatever's in the parentheses for y. So I'm going to have y minus 8 equals plus or minus, and then I'm going to have a over b, so 2 over the square root of 96, and then again, instead of just x, I'm going to have whatever's in my numerator, x minus 4. And I don't need to distribute or resolve so that it's y equals, because this tells me that I use the vertex of 4, 8 as the starting point for my asymptotes. And the only thing that matters after that is my slope, which is 2 over the square root of 96. Last example, we want to graph x plus 1 squared over 4 minus y minus 3 squared over 16 equals 1. So I'm going to start with identifying my center, which is the opposite of what's with x, so -1, and the opposite of what's with y, 3. And then I'm going to find a and b. So a is going to be 2, b is going to be 4. And now I'm going to find my asymptotes. So y minus 3 equals plus or minus. And because y comes second, I'm going to do b over a, so 4 over 2, and then x plus 1. I do want to simplify my slope here, so my asymptotes are y minus 3 equals plus or minus 2, parentheses, x plus 1. So when I go to graph, I start with my center, -1, 3. Then my vertices, so b is a distance of 4, so I'm going to go up 4, right 4, because x comes first. And I'm going to go left 4. So that tells me that my coordinates for my vertices are at 3, 3, and -7, 3. And now I need to do my asymptotes. So starting from my center, -1, 3, I'm going to apply a slope of +2. So there's one asymptote, and a slope of -2. And now my hyperbola gets drawn. So please let me know if you have any questions about hyperbolas, especially when it comes to writing the equation and identifying the asymptotes, because it's very important that you understand where a and b come from for a hyperbola so you can write the equations of the asymptotes in order to graph it.